How do we make our designs more resilient and sustainable? What tools can we use to quantify this? I'm going to talk about these things and more. My name is Tyler Lay, and I get to interview a concrete superstar, Tom VanDam, professional engineer, a PhD. Tom is an amazing dude. He's a technical leader at ACI. He is a crazy respected researcher and thought leader in the concrete world. The man is extremely forward-looking. He always has his finger on the pulse of the concrete industry, and by far the best thing of all, he is just a great person. I hope you have a chance to meet him at some time in your life. In this video, we're going to be talking about resiliency and sustainability and all of the things that make it up, the three-legged stool. We're going to talk about balancing these things in our design. I hope you like this video. It is far-reaching. We cover tons of cool topics. Check it out. Tom, tell us about your concrete story. How did you get into the concrete industry? We're so lucky to have you, by the way, because I know the asphalt people almost stole you. And how did you find yourself in your current position?
Well, those are almost two different tales there, but the concrete story probably goes back to really, honestly, undergraduate. As a lot of people, I think when they start their undergraduate degree, they're not sure what they want to be in life. I wanted to be an astronaut, so I was an astro-aero. Decided I didn't really want to be an astronaut after about a year or two and didn't want to work inside. So I thought, what engineering could I do and work outside? So the one I chose was civil engineering because I saw those people out there surveying and I thought that looked pretty cool. So I was an undergraduate at the University of Illinois. By the end of sophomore year, really getting into my civil engineering classes. And I believe it was at that time, it was CE 214, which then became 314, which was concrete. And I was very lucky to have a professor named Francis Young. Some people might know the name. Francis Young was the author of, in my opinion, the best concrete textbook, just called Concrete, with Mindus and Young. And so Francis Young was really instrumental in me becoming really interested in the material of concrete. But you go where the money's at, I think is an adequate or a fair thing to say when you're an undergraduate and trying to pay tuition. And so I ended up doing my initial undergraduate research in asphalt. And I worked in the asphalt lab there, got a research assistantship, went on and continued to work in asphalt for my master's degree under Sam Carpenter at Illinois, but took advanced concrete as well. And so I really had interest in both materials, but was really essentially an asphalt guy. Through a series of, going into Peace Corps, following my master's, coming back working as a consultant. I ended up back at the University of Illinois in the early 90s pursuing my PhD, and at which point I again found myself in a classroom with Francis Young and David Lang, and that's when my interest just continued to grow in concrete and started getting bored with asphalt actually. And what I discovered is concrete with the chemistry, the microstructure was so much more interesting than the pure physicality really of asphalt mix design, as well as the fact that concrete is used everywhere and asphalt has very limited applications. You're pretty much stuck working in pavements with asphalt. And so later when I took an academic job at Michigan Tech, I started really as a faculty member primarily in asphalt, set up the first super pave lab in Michigan, did a lot of asphalt research projects, but also managed with a close colleague of mine to this day is Larry Sutter, who at that time was working in the lab at Michigan Tech. We won a study with the Federal Highways Administration where we were looking at the durability of concrete. And that's really what kind of launched my entire career.
Man, that is a really cool story. And I think that's one of your strengths is that you're so diverse. Not only do you have lots of different experiences, but you have lots of different material experiences. And I think that's a super strength of yours. So when someone asks you about what you do for a living, like right now, like how do you answer that? And tell us, what do you do?
I always answer it, I'm an engineer. And I think I'm told I'm an unusual engineer. I don't know what that means and whether that's good or bad, but I definitely self-identify as an engineer, as someone who takes scientific fact, or at least what we consider to be fact, and then translates it into applicable solutions to real everyday problems. And as I mentioned, I used to be an academic working at Michigan Tech. And honestly, I burned out on kind of the academic life because I really want to do more applied type of applications where I can take what I know and then actually using engineering skill, bring it to real life everyday problems and solve those problems. So yeah, I'm an engineer.
That's awesome. How do you define sustainability and resiliency? Now, I know these are areas that are one of your expertise, something that you are definitely looked upon to give guidance to a lot of different people on. But how do you define sustainability and resiliency?
Well, defining it is kind of maybe the way I came to it. And you know, we know there is a UN definition that is commonly quoted. I believe it's from 1987. I don't remember it. I won't try to quote it, but it has something to do with, you know, making sure that we, you know, live well today without compromising the ability of future generations to live equally or better. And so, you know, that's how we come at it. But for me, my journey to sustainability really came through concrete again, knowing that concrete is used in almost every civil engineering structure in the world. It's the most commonly used material on the planet by mankind after water. Roughly a cubic meter of concrete is used per every man, woman, and child annually. And as a result, civilization itself is built on it, but it also has a big environmental impact. And so as someone who essentially began my concrete professional career doing durability and continuing in that vein, I saw how durability and making concrete long-lasting was intimately linked with the concept of sustainability. And so my own personal definition of sustainability is, first and foremost, we have to adopt a life cycle perspective. And what that means is we cannot just look at our decisions as influencing to construction a project and we walk away, or to the end of the warranty period a year or 5 years later. We have to look at our decisions today as influencing the life of that project and then the next life of that project. In other words, we take a project from inception all the way to construction through its entire life cycle until at some point we're going to recycle that or reuse it back into a new structure or into something useful. And so once you adopt that life cycle perspective and employ it to the economics of the project, which we're all or should all be familiar with, life cycle cost analysis. But we also can do environmental life cycle analysis where we do the environmental accounting over the life cycle. And so we take it all the way through from project inception all the way to the very end of life. And then we can also look at the societal impacts over that life cycle. And when you start to balance out those three legs of the sustainability stool, so to speak, we need to balance each of them. We need to consider them all. We need to weigh them all in. And I think that helps us then make better decisions.
Sweet. So resiliency, though, now that's a word I hear people use a lot today. And think I know what it means, but what does it mean to you?
Yeah, but resiliency is definitely related to sustainability. I would say the popularity of the word resiliency has really taken off underneath the current administration. I won't mince words about it. It's not a secret that the new administration is different, has a different philosophy than the past administration on the impact that human beings are having on the environment and on the climate. I think most people recognize climate is changing. And so whereas sustainability had a lot of focus maybe on decisions that we make as far as greenhouse gas emissions and other types of toxins being released in the environment, waste, those kind of things, the emphasis on resiliency is more focused, I think, in reacting to the changing climate. And so when we do our resilient design, we are looking at something where maybe this roadway network, and most of my work is in pavements, has throughout recent history, as it was designed to be dry. We did good ditch lines. We're not having issues with flooding. But all of a sudden, climate patterns have changed, and these formerly dry areas are now becoming inundated, for example. Another area is changing temperatures, whereas we know the climate is getting hotter. We know that the heat waves are going to be longer and more intensive. We know that winters are going to be more mild. And these factors actually have an impact on pavement performance. And so a lot of research has been done looking at the impact of changing temperatures on pavement performance and trying to bring that into some of the models such as the AASHTO Pavement ME software. So when you look at resiliency, it's really more of a response in trying to increase the robustness of our infrastructure in response to this changing climate.
These topics are not ones that are always comfortable for people to talk about. When I see my young students, they get it, they understand it, they buy in, but sometimes people that are practicing engineers, it's kind of harder for them to get their hands around. Why do you think that is?
Well, actually, we're lucky. The younger people, it's easy for them to get their hands around it. It's much more difficult when you're in North Dakota doing a pavement workshop and you're talking about sustainability, and that big contractor in the front row has got his arms tightly crossed across his chest. I think what's happened is it's become politicized. And so instead of us maybe trying to look at trends, climate trends and models and trying to predict the future, what we've done instead today is our discussions become so politicized that if you are a climate change denier, quote unquote, you're clearly someone who would be a Republican, whereas if you are, a tree hugging, we need to save the planet person, you're a Democrat. And it does us a huge disservice. I mean, the reality is we have to deal with facts as engineers, and we have to make good decisions. And so the better way to approach this is when you talk to people like the contractor in the front row in North Dakota, and that happened to me, you basically come to them and you talk about impacts that are occurring and how that really matters every day to what we do. And so everybody, I think, wants to do a good job. Everybody wants to make better use of our materials. They want things to be more economical over the life cycle. We share so much common value on these things. You got to find the common issues and try to gravitate towards them. Economics, almost everybody can agree that we need to make good life cycle economic choices. Environmental, sometimes you maybe have to stray away from greenhouse gases as being the major factor, although that is a very important consideration, but talk about toxicity. One thing that I kind of would talk about is actually how CO2 increase in the atmosphere, which is undeniable, actually makes poison ivy more virulent and more, people are more allergic to it. So everyone can relate to that who's allergic to poison ivy. So you try to find a common language, you work with that, and recognize the politics exist, but diffuse those situations because ultimately we all really do have the same goals in mind.
No, I think that's well said. I think that's right on. And I think it's also a topic that as far as engineers go, they're not as used to designing for. Stress and strain, we've heard a lot about that for a long time. It was something we heard about in school. Durability is getting more popular and people are talking about it. But when it comes to quantifying things like long life and what that means and what that means for our environment and carbon footprint and greenhouse gas emissions and what that means and how to quantify that, I think that's just people that they've never been trained how to do it. So it's hard for them. It's kind of strange and challenging. And that leads to my next question. So how do people quantify this process? How do they quantify sustainability, resiliency, something like that in their designs?
Yeah, no, that's a really good question. I think that some of the more simplified approaches that have developed over time They started with maybe LEED or other rating systems in which building elements were rated, and then buildings would be given bronze, silver, or gold, platinum status as far as how many sustainability features they implemented. Similarly, we have systems on the pavement side like green roads, a very, very good system that has continued to evolve and is being used. I think ASCE, for example, has their Envision system in which individuals can be trained and it can be brought forward to look at the different features of an infrastructure project and try to build in some elements of sustainability. My feeling and what I like to see is the movement towards life cycle assessment. I mentioned that earlier, I believe. This is an environmental accounting. It's based on sound science. It's rigorous. It's robust. It's standardized. It's independently reviewed, so it's somewhat immune to industry influence. And so when we come at it with a tool like life cycle assessment, that allows us then to actually quantify environmental impacts over the life cycle in a much more robust manner than we do with simple rating systems. You couple that with a life cycle cost analysis for the economics, and you have two of the three legs are actually very, very well quantified. The societal impacts are more difficult, maybe a little bit fuzzier, but also there are methods to quantify those and try to bring them in. And I'm not one who's a fan of actually monetizing, for example, environmental impacts. I think we ought to keep these things as separate channels and then balance out those channels. Trying to bring it to a single metric, I feel is a mistake. So the tools are available. There are professionals out there that do this work that can be hired to assist. And we see it really advancing. I mean, you see certain DOTs are starting to really advance this.
That's totally awesome. So if people wanted to get more information, where's a good place for them to go to get some resources and some of the things that you just mentioned? Like, do you have any websites or any reports or something where they could go get some more like concrete data? Got that?
Yeah, I got that. And like if you're in general, I do think Envision is something ASC again is worth investigating. That would be maybe some very good general broad knowledge. If you're interested in pavements, this is a shameless self-promotion, but I would go to the FHWA Sustainable Pavements program website. You could just type FHWA Sustainable Pavements and it'll get you right there. And in there you'll find a massive amount of resources from a reference book that's like 460 pages that I would say don't print it out because that would not be very sustainable. But that covers both asphalt and concrete pavements in immense detail. We have various tech briefs on there. We have presentations that were done and lots of other very helpful materials. So that's really the clearinghouse in my mind for pavement sustainability issues.
That was great, Tom. I'm going to put those in the notes below. And what are some emerging topics? You've given us lots of good information here. What are some emerging topics in these areas that people should know about, or some things that are kind of coming up that they haven't heard about yet?
Well, I think I think most people that are somewhat tuned in, we've talked about resiliency. You look at, this is something everybody can get a handle on. If you look at coastal flooding, for example, due to storms, but also just due to rising ocean levels. There is no debate about this happening. Miami, for example, is seeing their streets becoming routinely inundated, even during clear weather, just if they get a higher than normal tide. So with coastal inundation and then the flooding such as we saw in the Midwest, we just had in Houston. So this idea of resiliency and how to make pavement structures more robust to resist the influences of flooding. That's one area I think that's really taking off right now. A second area is back to what we were talking about with life cycle assessment. The baby steps in that are to try to come up with this quantification of environmental impact for different materials. So if you imagine we're putting concrete together, we have aggregates, we have water, and we have cement, and we have supplementary cementitious materials, and we have admixtures. And each of those component materials, for example, has its own unique signature as far as an environmental impact. And how we account for that is complicated, but also there are rules that exist to allow it to be rigorous. And so we can track, for example, the environmental impact of making clinker. We can go from mining, crushing, transporting, putting it into the kiln, grinding the clinker, shipping, and then shipping it. And by doing that, we then have a very good understanding that for a ton of Portland cement, United States of America, roughly 0.927 tons of CO2 are generated, CO2 equivalents. That's roughly, I believe, the number that's currently used. At the same time, we can quantify that for fly ash. Now, you would think fly ash, oh, that's a waste product, man. That stuff's going to the landfill. Well, there's the accounting system is if it has value, if it has economic value, it's not a waste, it's a byproduct. And as a byproduct, you have to figure out how to account for maybe all of the CO2 that went into the production of the fly ash. And so how much of the burning of the coal gets assigned to the fly ash is one of the things that gets worked out in this process. So the bottom line is we take all these components, add them together, and ultimately a rule is set that helps us determine an environmental product declaration, something like a nutritional label on a can of soup or whatever, that shows at the gate, when that concrete truck is sitting at the gate ready to leave, how much embodied energy exists, how much CO2, how much ecotoxicity, whatever impact factors we want to see, they are there. And that every ready mix producer within an area could be in a situation of coming up with these kind of EPDs. And for example, this is something that right now Caltrans is experimenting with, because in California they are very concerned about their carbon footprint. And so for their asphalt, for their concrete, for their steel, for their plate glass, for their aggregates, these are different things that they are generating right now for concrete, for asphalt, and aggregates on a voluntary basis, but they're generating EPDs. And so this is kind of an emerging thing that is of interest, and that interest continues even today in multiple states.
So you are very involved in this area, and I know that you've worked on a lot of innovative projects. I know you hear about all kinds of innovative projects. What could you give the viewers some details about some of the most innovative use of sustainability and resiliency?
You know, it's a really fascinating thing. The first thing I'll tell your viewers is definitely check out the Green Roads site. Dr. Steve Mensch at the University of Washington was one of the developers and a strong advocate of it. But go to check out their website, because they do have a lot of examples of projects that have been rated by Green Roads, in which they show very definitive selection criteria or decisions that were made to make a pavement more sustainable. In my professional experience, one of the agencies that I have witnessed that has been one of the more innovative with sustainability has been the Illinois Tollway. Under the direction of the Tollway, they've been able to go forward and really look at trying to introduce environmentally and cost-effective way recycled materials for base, within the mixes themselves, two-lift concrete, fractionated coarse wrap as aggregate in concrete mixtures, higher wrap contents for asphalt. Many different techniques have been advanced by that authority or by that agency. And so that's been some really good work. Another example, and it's something that we didn't have anything directly to do with, but we were able to document, was some work that was done for the access road to Denver International Airport. It's called Pena Boulevard. It's an interstate type pavement, 2 lanes each direction divided, and they had to reconstruct this road really before its time because of alkali silica reactivity, a durability problem. So when they were reconstructing the road, the original design was sketched out basically to take up the concrete pavement, take it off site, crush it, bring it back to site, relay it as base, and then put the new concrete on top. And the contractor in this case was able to instead convince them to try let's rubbleize the existing concrete in place. So by doing that, they also use a reduced cementitious content mixture. They showed dramatic savings of overall in every environmental category. And so there was a case where they were going to recycle the material to start with, but we also compared what it would have been the differences between using virgin material and then the recycling method that they were choosing, and the environmental difference between those two was very modest. Once they decided not to pick that material up, move it off site, crush it in another operation, move it back on the site, that's where your environmental impact was. And so it was a really innovative solution, and what was best about that solution, it saved them a lot of money as well.
If you could give a practicing engineer today a suggestion on a simple steps that they could start doing today to make their designs more sustainable, more resilient, what would it be?
The first thing is to educate yourself. Avoid the political traps and just educate yourself as an engineer doing the most cost-effective, long-lasting, environmentally sound thing for your clients. Your clients as an engineer are going to be the civilization, people, agencies, state DOT, local agencies, cities, counties. They are interested in this topic. So educate yourself on what you can do. The things that you can specifically do is, I always tell people the first place to look for your materials on like a construction site, especially pavements, is in the existing pavement. So if you come out to a site and your job is to reconstruct an existing roadway, your first source of raw material for doing that is the existing pavements there. So how can we effectively recycle that, and in a way that doesn't compromise long-term performance, but with the least amount of movement of that material? So really efficient in-place recycling techniques are the way to go. Second thing is, if you're working in the concrete industry, your CO2 is tied up in the clinker. That little wonderful nodule that comes out of the end of the kiln is responsible for about 90% of the embodied CO2, or the CO2 associated with ready-mix concrete at the plant. So that's huge. There's very little more that we can do to reduce that clinker content, or that CO2 associated with the clinker. So our challenge is use less clinker. We can use less clinker by looking at blended cements, ASTMC 595 cements, blended with pozzolan, slags, or limestone, or multiple, ternary. We can look at how to use more SCMs effectively for replacement of cement in our mixes, fly ash, slag cement, natural pozzolans. And we can look at reducing our cementitious content overall through optimized aggregate grading. And so in other words, instead of putting 6 sacks or more of cementitious material in these mixes, can we cut that back by replacing it with aggregate in an efficient manner? So we not only reduce the cement content, reduce the shrinkage of that mix, we're going to lower the alkali content in that mix, and if we do it right, we get a more workable mix. And all of those are win-win situations because they save money. So those are the things that I would be looking at. First of all, educate, look at these options, and through this process, I think I opened up with this, is develop that life cycle perspective. It isn't about, hey, this solution has the lowest carbon footprint today. It's about, this has the lowest carbon footprint over the life cycle, or the lowest cost, or the lowest, we want to lower all of the impact factors over the life cycle. So development of life cycle perspective.
Man, that's a great answer, and that's a really good answer. And I loved how you talked about hitting the facts, and I love how you talked about thinking about your clients and what they want and what their needs are, and then looking at your local resources. And then you said all the same stuff I always say about clinker. I think you're dead on there. So I think that's an awesome answer.
I do want to just add, and this is really important for students to understand. When you get down to that local level, the public is expecting their engineers to provide them, right, with cost-effective, long-lasting, but also these environmental factors. Again, regardless of your political affiliation, they really are important. People want their built environment, to be social, right? They want it to be a great place to be. They want their downtowns. You've heard of complete streets designs, all these things. I will find in Nevada, which is not, necessarily a bastion of liberal thought, this is what they want to do at these local levels. So really drill down, look who your client is, meet their needs, and you'll have a good career, satisfying.
No, that's an awesome suggestion. So what happens though, if you have some of these things that conflict? All right. I mean, I think that happens sometimes, right?
Absolutely.
If the thing that maybe has the lowest CO2 may not be the most economical. How do you handle that?
Well, the great thing about that is almost everything we do is one big fat optimization problem, right? I mean, there is very rarely a straightforward answer. And if there is, you're probably not thinking deeply enough. And so when we find things, for example, we know that the use of fly ash is good, quote unquote good. But is it really? I mean, if we have a sea ash, is putting 15% sea ash a good decision when you might have sulfate in the soil or a highly reactive aggregate? And the answer is probably not, right? It could very well make it worse. You might need 35% sea ash, in which case maybe you're not getting other properties of the concrete that you want. So the first thing I would say is back to education. What are the impacts of these choices? What are the impacts on the engineering properties of the material? Strength, your stiffness, your shrinkage, the things that matter in your design. What are the impacts on your durability long term? What are the impacts on your constructability? How do we balance that out? And then ultimately, this idea of how these things are going to impact recyclability. Are we going to do things that will make it difficult to recycle that pavement back next time? So thinking broadly and I like to think of it as various dials, right? One is your economic dial, one's your environmental dial, one is your societal dial. As we spin those dials, it is going to have a change. You got to balance it, and it's really it's poor engineering to allow yourself to get skewed into any one category. You need to balance those out and find those sweet spots and find the win-win scenarios where, hey, I reduce cement content by using SCMs and reducing my overall cementitious content of a mixture. Guess what I've done? I've saved the client money. I've made a more durable mix that's going to last longer, and I've made a far better environmental decision. So that's the key.
No, I think that's a great answer. So I guess, in summary, it's not easy, but we need to start. We need to start doing something. We need to start trying and thinking. And even if it doesn't work the first time on your first project, you should learn from that and then try something else, I guess, again. Just to change directions just a little bit. I like to ask this question to people because I like to, I guess, always look for new things. But what area in civil engineering or in infrastructure do you think needs to be reinvented and why?
That's a very difficult question. Reinvented. I do think what we want in our engineers are thinkers. We do not want folks that are just expecting to go into a job, pull a lever, and an answer comes out. I think that is the challenging element of educating, because I'm a consultant. We hire students, and the first thing we need them to do is turn a crank on a design or send them into the field to do an inspection. And so, the kind of the day-to-day work we get is not necessarily exciting. But at the same time, we need to stay sharp and interested in the field and look for those opportunities to innovate. And so I think within our educational system, I'm not sure how we can do that. So clearly managing information is key, I will say, and I think you know this. The good thing, again, the young people know this. These days when we generate data, I give it to our younger engineers, they don't show me a table with a bunch of data. They give me a KMZ file linked to Google Earth so that I'm now visualizing, the back calculated subgrade moduli over the project versus, looking at a table or a line chart. And, I think that's great. We need to keep moving that along. We really need to advance sensor technology. I think in civil engineering, I think the next really bright field is linking it with sensors and wireless technology and let our infrastructure talk to us. I mean, heck, Tyler, we talk about alkali silica reactivity. My opinion is we ought to be measuring pore solution chemistry on the fly. If we can embed sensors in concrete and watch changes in pore solution, I think we're going to go a long way in solving a lot of our durability issues.
Amen.
So I think that, really getting the intersection with technology and is really important. I will say we have lost so much in the appreciation of concrete itself. I mentioned at the very beginning, what got me into concrete was the fascination with microstructure, the fascination with, hydration and how we know so much, and yet in a lot of ways we know so little. You have your hydration theater going. It's cool, but is that really what happens? I mean, do we really understand? And so this is a very, very exciting area. Very few universities are teaching even a concrete class anymore. Almost every civil engineer will work in concrete. Your hydraulic structures, your water treatment, your foundations, your columns and beams in a building, your pavements or whatever. I can't think of a field of civil engineering where they're not working in concrete, and yet we seem to have lost a fundamental understanding of why concrete works. Simple things like paste is what shrinks. If you understand that simple thing, you can understand how to maybe make better performance, and yet we've lost it. So we got our challenge ahead of us. That's no doubt.
So now, if you were going to give advice to a smart, driven person about to enter the concrete world, what would you tell them?
Well, I would tell them if they're smart and driven, that their opportunities are broad and they're exciting. They're probably not going to get rich. Probably tell them to go back and get an MBA. No, I'm just kidding. But they will be able to make a decent living at it. And what I would tell them to do is gravitate towards things that interest them. Don't allow themselves to get trapped into something that's boring, that they go into work and they dread it, and at the end of the day, they can't wait to leave. There's a lot in this field and a lot in civil engineering in general that's absolutely exciting. And so just find yourself a place in this industry that every day you feel challenged, every day you feel like you can go out and make a difference. And then stay educated, stay engaged with the industry, get involved at ACI. Get involved locally with your ACI group and get involved nationally. And just keep questioning and realize that change is difficult. I was talking to someone yesterday about this. One of the reasons that the Titanic hit the iceberg is they threw it into reverse. So they saw the iceberg, or they were notified an iceberg, they ordered full astern, and what that did is the flow stopped going over the rudder and they lost steerage. So actually, if they would have kept that speed or even accelerated, they probably would have had steerage and missed the iceberg. So don't throw yourself into reverse. You're going to run into challenges. There's going to be icebergs ahead of you. I'd say keep steaming and just keep steering, and avoid the pitfalls.
That's a good advice, man. I've never heard that story. That's really good advice, though.
Yeah, well, it's true about the Titanic, as far as I know, as a sailor. If you lose flow over the rudder, you got nothing.
That's cool. So tell me about something that you're working on that you want to share with others. This could be a project you're doing or a research project, whatever. Something that you're excited to tell people about.
I'm pretty lucky in a way that I do a variety of different things. So on a practical sense, we did the pavement design for the reconstruction of Virginia Street in Midtown Reno. This is like a $70+ million construction project. I got to redesign the concrete mixes to avoid some of the shrinkage issues there. I've been getting a lot of fun interaction with the contractor and the supplier to try to execute my vision. But it's the kind of thing that you feel like you can make a difference, and it's practical. And you're able to get the agency into the room with the contractor, with the supplier, with the designers, and talk about what we're trying to accomplish. And I find that's great. Another project right now I'm working on, I am a principal investigator in the FHWA Sustainable Pavements program. Lots of good activities there. But right now I'm working with Steve Mensch on that resiliency guidebook. And that's, I think, really coming along and is going to be a good piece of work. The other thing is that, really trying to advance just, again, this isn't advanced stuff, but using kind of advanced techniques to characterize pavement structure. And these techniques, when I say advanced, they're from the 90s or the 80s, I'm sorry. So they, it takes a while for people to get used to these kind of innovative ideas. But using falling weight deflectometer to back calculate layer moduli to use in design. I mean, I was doing that when I left and started my first consulting gig after my master's, and yet there are so many places where we're still trying to advance that as, this is much better than just coring. And then we're having an opportunity to try to bring in new technologies. I mean, I'll give you an example. We're proposing the use of the Mira, which is an ultrasonic tomography device for concrete forensics or evaluation. Resistivity is something that I'm having a chance to advance, and really trying to advance the formation factor concepts that Jason Weiss has been bringing forward. So, there's a lot in this field that allows us to talk to people that are motivated, that are interesting, and there are people that are building all of this stuff around us. And if you can make even a bit of progress, man, if you can push that rock up the hill even 1 foot and keep it there, it feels rewarding. And so those are, there's a lot of other stuff, but those are kind of just a little spectrum.
And that's awesome. That's a great answer. You're a very, very busy dude. And thanks for all your hard work and all you do for our industry.
Yeah, one final word of advice, if I may. If anybody's doing concrete flat work, figure out how to do jointing. Read ACI technical documents on jointing, please. That's my final word.
There you go. So where can people find more about you and what you're up to? So if people become a Tom VanDam freak, because they all will, they all want to follow you.
I'll probably be very disappointing to you because I keep a low profile on social media. I don't friend people on Facebook that I work with. I don't really maintain my LinkedIn page. I would say go to ACI and go to the durability meeting and or at the mixer. That's where to find me. Find me there, and I'm very active at ACI. I'm on TAC. I used to chair 201. I'm on 325, which is pavements. I'm on 240, which is natural pozzolans. I'm on 232, which is fly ash. So I would say ACI is your best bet.
Okay, so go to ACI if you want to find Tom VanDam.
You got it.
That's the answer.
And maybe I will someday update my LinkedIn page. Maybe.
Do you have any other messages that you would like to share with my audience? Any other final words or thoughts? Anything like that?
Yeah. I guess my final words, if I could, is have a life. Concrete's a blast, but we got one bite at the apple here, at least that we know of. And so when you're approaching everything in your life, make sure you appreciate every little thing. Everything's great. We're lucky people, most of us, and take what life is giving you and try to find enjoyment in everything you do. If you find yourself miserable doing work or miserable at home, change it. change it to the best you can, and keep your life exciting all the way through.
Man, what a great way to end. Hey everybody, thank you so much for watching. Again, if you like this video, please give me a thumbs up, subscribe to my channel, and again, comment below. What did you agree with or not agree with on this conversation? Who else do you think I should interview? I really appreciate you. Take care. Bye.